In this lab, we will build a motor that uses electric charges and magnetic fields to make a coil spin. An electric motor is an electric machine that converts electrical energy into mechanical energy. Most electric motors operate through the interaction between a motor's electric field and a winding current to generate force. Some examples of motors in use are car engines, water pumps, ceiling fans, washing machines, and much more. To build this motor, we need one battery, 2 paper clips, a piece of sandpaper, and a rubber band. We use the battery as the source of the electricity, the paper clips as conductors and also to hold up the wire, the rubber band to hold the motor in place, the magnet to create the magnetic fields and cause the coil to spin, and of course the coil that would be the item that was spun and had magnetic properties. We wrapped the coil around the magnet because it was a circular object that would create a shape that wouldn't interfere with the magnet but would also spin pretty easily. And one modification we made was that we adjusted the height and the angle of the paper clips in order to have the coil or the wire directly above the magnet.
In this graph, you can see that the purple line represents the coil, or the magnet wire. The kind of blue diamond shape with the north and south represents the right-hand rule of the north and south poles of the magnet wire. When current is passing through the magnet wire, it creates a circular kind of current that goes through the wire and then exits out the other side. This, in turn, because of the right-hand rule, creates a north and south pole. If you reverse the current through the wire, it switches up the north and south pole so that the north will be where the south is and the south will be where the north is. So on the wire, there are 2 parts that we sanded. One part which we sanded the whole part, and the other half where we only sanded one half of the wire. On one part of the wire that is sanded and the other part is not sanded, which means that the insulator is still there. The insulator, when it's touching the paper clip, doesn't allow current to pass through, which doesn't allow magnetic field to allow the coil to spin. When the conductor part of the wire is touching the paper clip, it allows current to pass through, which allows the magnetic field to allow the coil to spin. It is important for the magnetic field to turn on and off because during the rotation of the coil, the magnetic fields are basically repelling each other. However, once the coil reaches its quote-unquote mid-turn, the poles are then attracted to each other. That's why it's important to not sand the side of the coil so that will be touching the paper clip since it's an insulator and breaks the electric current. This then causes the coil to finish its rotation, starting the process over again and allowing the coil to spin.
Is my life, my love, my way? Wonder where can she be? Days, endless days, nights dark as night.
The forces are balanced because the force of gravity is pulling down on the coil while the force normal is pushing up on it. Now there is a torque on the coil, but the forces are still balanced. And on one side, the forces of magnetism are pulling down, and on the other, they're pulling up, causing the coil to spin.